Hello everybody. Today's lesson we're going to be doing about electromagnetic waves. Now if you remember, I started this with you before we had to leave, and I went through that just like in GCSE you need to know the 7 different bits of the electromagnetic spectrum. So we've got radio waves, we've got microwaves, infrared, visible light, ultraviolet, X-rays and gamma rays. Okay, and if I taught you for GCSE, you'll remember the delightful mnemonic at remembering all the different words. But you're basically going to remember this because there's 7 of them. In the middle it's visible light. You've got 3 above it, 3 below it, just learn it, okay? Now, it is a spectrum, so there is long wavelength radio down to short wavelength radio, long wave, micro, short wave. There's all different wavelengths, but the pattern with the wavelength is at the top there, the wavelength is bigger, and the frequency, it goes the other way. The frequency gets bigger down this end. Now also the energy gets bigger down that end. When we look at quantum next week or the week after, you look at the equation for that as well. So frequency gets bigger, energy gets bigger, and the danger gets bigger as we go down this way. Okay, so we went through last week, didn't we? You've got to know a typical wavelength, but the wavelengths can be any value whatsoever. That's what a spectrum is. So radio waves, I said, remember that they're about 1 times 10 to the 2 meters. Microwaves, 1 times 10 to the minus 2 meters. Then do you remember infrared and visible light? You had to be a bit cunning on how you remember them. And I said to remember 2 words, you need to remember, 2 numbers, you need to remember 7 and 5. And if you use 7 times 10 to the minus 5 for infrared, you can use 5 times 10 to the minus 7 for visible light. Okay, then you can just go 10 to the minus 8, 10 to the minus 10, 10 to the minus 12, and you're all sorted. Now you can work out a frequency from that because you know, so all these are wavelengths. I shouldn't have written on the frequency side, should I? All those are wavelengths in meters. You can work out the frequency because you know the wave equation, which is V equals F lambda. Well, for electromagnetics, we can say C equals F lambda, where C is the speed of light, which is 3.00 times 10 to the 8 meters per second. Okay, so that's the first bit. You need to know what they are. You need to be able to use the equation to find things out. Now, some things about them, and this is on page 221 of your textbook. So you need to, for today's lesson, I'll put it on the classroom as well, be reading page 221, and I think it goes to 223. Yes, it does, of the textbook. So it tells you all these waves can travel through a vacuum. If they're in a vacuum, they're travelling at that 3 times 10 to the 8 meters per second. If they're travelling through anything else, they slow down slightly, and you can work out how much they slow down using the refractive index. Okay, we've done that already, but it might be worth having a little look over it. Now, electromagnetic waves are so called because they all have got a magnetic wave and an electric wave interlocked and at right angles to each other. That's as much as you need to know about that at the moment. They're all transverse waves, and because they're transverse, they can all be polarized. You can also reflect, refract and diffract them, and you can show interference with any of them. Now usually we show interference with the visible light because we can see it. You might remember I had the microwave emitter and receiver. You can use a microwave emitter and a receiver to show the same patterns as you would with the Young's double slits. Didn't get time to do that. I might nick it and nick the equipment and have a go at setting it up one day. Okay, so if you read through the book on page 222, it will tell you about the uses of electromagnetic radiation, and it will tell you that this lot's non-ionising, the stuff at the top here, because it's not very energetic. Stuff at the bottom is ionising because it's got a lot of energy, okay? There's 3 sorts of ultraviolet light. You can read through it in the book. There's UVA, UVB and UVC. Okay, so have a look and see what it's the UVB that's the dangerous one for sunburn and skin cancer. Have a look through what the other one's about as well. Okay, so you're going to read through the book. There's not a lot else on electromagnetic waves, and I'm going to set you some lovely exam questions to do. Now, for the lesson on Thursday, it's going to be a bit more video because I want to show you some stuff about stationary waves, or they're sometimes called standing waves. So I will upload that probably on Wednesday because I'm in school tomorrow stealing the equipment that I need to use for that. Hope you're all safe and healthy, and email me with any questions that you've got. Hopefully see you soon.